We're going to review for our test that we're having on Friday over exponential functions. To start with, let's make sure that we understand domain and range. Remember, domain is x and range is y. When you're looking at this, if it helps you to think about, we have our lowest less than our x or our y less than our highest. And remember, we can look at those borders. We have a left, right, up, down border. So when we're talking about domain and we're looking at our x, you can see that in fact we have a bottom border of our left border of -2 is less than x, and this open circle versus a closed circle. So remember, if it is an open circle, it is just less than. If it is a closed circle, it's going to be or equal to. So because this is a closed circle, we need to make sure we put the line underneath. We do not have a right side border because we have this arrow. So then we're done with this one. Now you'll notice in the answer choices that all of our letters are in fact listed first. So we could rewrite this. If we flip-flop the whole thing, we have to flip-flop that inequality. So x is greater than or equal to -2 versus -2 is less than or equal to x. So mean the same thing, it's just written a different way. When we talk about range, we do have a bottom border here at +3. This is counting by threes here. So 3 is less than y. And again, it is a closed circle, so we need to have the line underneath. We do not have a top border, again, because of this arrow. And again, we can flip-flop it. Y is greater than or equal to 3, which would be this answer choice. So please remember domain and range, x's and y's. Number 2 here is also domain and range. You could do a couple of different things. You definitely want to make sure you're looking at this and you can graph it. So I'm going to go to my calculator here and make sure when you do that, you type it in correctly. You can also do this in Desmos, which will be embedded in the test as well. So this one, if I sketched a little graph, I can see that -4 is in fact my y-intercept. And we're doing this. And it's getting real close, you can see, to that x-axis, which is that asymptote that we talked about. So when we're looking at this, we can talk about our domain and range again. Now, I don't have a left or a right boundary. So domain is all real numbers. Our range, we do not have a bottom boundary, so we're not going to have anything listed first. Y is we always have less than, and here, this is where y equals 0 is what the asymptote is. So y is less than 0. We're approaching 0. We are not going to put a line because remember, an exponential does not touch that line. It just gets really close. So make sure you read super careful. This says domain is all real numbers, but it also has greater than or equal to 4. So that won't work because our domain was all real numbers. Range is all real numbers less than 0. This says y is less than 0. Double check them all. Domain all real numbers less than or equal to 0. No. Range all real numbers. No. So make sure you check all of your answer choices. Number 3, when we're talking about exponentials, it says the function v of d equals 900 times 0.85 to the d power. Give scientists the number of people who test positive for a virus on d days after an outbreak. So that d is really where the x is. Circle the correct answer for each blank to complete the statement. The number of people who are initially, so that is our A, 900 is our A, infected by the virus. The number of people who test positive, increasing or decreasing. So remember, if B is bigger than 1, then it is in fact increasing. If B is less than 1, it is decreasing. Here's my B, 0.85, that's a decrease at a rate. So remember, your rate is going to be 100 minus your rate gives you the B. So 100 minus something gives me 85. Well, I know that 100 minus 15 gives me 85. So 15% is going to be the percent that it goes down every day. The 85% is what stays. This one is also similar to that. It says this is the insect population after X months can be modeled. So again, we have our A and our B. Circle the ones that complete it. So initial is A. So our initial number of insects was 18. Now this one, the B is bigger than 1. So this one happens to be increasing at a rate of, and again, so now when we're talking about increase, we're not subtracting from 100, we're adding to 100. So our B for this one was 130. So 100 plus 30 is 130. So we increased at a rate of 30% each month. Sometimes they'll write it as a decimal. In this case, they wanted the percent. They give us a table here. It shows the value in dollars motorcycle at the end of X years, which exponential function models the situation, and how much would it be worth at 7 years. So this is going to be, you can do number 4 list and spreadsheets. We did talk about when it's exponential. Pay attention to those words. We're going to do menu 4.1a, or if you're putting this into Desmos, you would add your table, and then you would type in y1 squiggle ab to the x1 power if you're using Desmos. So I'm going to have my calculator right here. Please make sure if you're using the yellow calculator that you do in fact remember to put x and y, but also make sure you start a new document so that you can don't have any numbers from before that might interfere. So remember, on a horizontal table, the x is on the top and the y is in fact on the bottom. So I mistake there. Very important that you take your time typing those numbers in so that you don't mess up, because that will mess up your data, right? C1, menu, 4.1, and you can see A here is exponential, which is what we want. X and Y. Enter, enter. So this is going to give me my A and my B. So my A is 9,000. My B is 0.9. So that is going to be answer B here. And then after 7 years, so you can do a couple of things. You can either plug that 7 in place of X and use just the calculator function either in Desmos or on the calculator. Or if you're using the yellow calculator and you've just done this, you can do Control T, enter, and we are looking where X is 7. So I'm going to go down, 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 down. X is 7 at 43.04 and 67 cents. So if you were to use that in calculator mode as well, you would get the same thing. Here we have another table. We're going to plug that in. So again, if you're using the yellow calculator, make sure that you start a new document. Don't just add a page, because sometimes your data will get confused. So -2, -1, 0, 1, 2, and then 12.5. And probably this is the most tedious part. Just make sure you're putting that information in correctly. 0.92. And again, it tells us, it doesn't say, it says exponential here, but also you could see it in your answer choices for 1a, x and y. And you can see here that we have an a of 18 and a b of 1.2. Now, these b's are all in fraction form, but I can't eliminate a and c because my a value doesn't match. So at this point, you could do a couple of things. If you wanted, you could go to Desmos, you could type in 1.2 and then click the little fraction button, 6/5, so that you could see, in fact, it would be answer B. Write the function. So this is going to be where you're using list and spreadsheets, just like we've been, or again, if you're using Desmos, you're adding that table. So it's not any different than what we were just doing. It's just giving it to you in a graph form instead of a table. So X and Y. Make sure you have that negative if it is a negative. For 1.25, for 1a, x and y, there you go. So we would write this y equals, our a is 1 times, you could write 0.25 to the x power. You could also write this as 1 times, if you wanted to write your b as a fraction, you could 1/4, or because we're multiplying by 1, you could even just write 0.25 to the x or 1/4 to the x, because when you're multiplying by 1, you don't actually need it. So any of those answers would work. Here we have a graph of a pufferfish. So the number of pufferfish since 2012, modeled by the exponential function graph. On the grid, x is the number of years since 2012 based on the graph, which statement is true. So since 2012, the number of pufferfish has gone up by 50 each year. So I'm gonna zoom in here. So this first year it did go up 50, but the second year it went from 150 to about 225, which would be a 75 increase. So because it uses the word each year, that one is not going to be true. Okay. If it said in the first year, then we would be fine, but the wording is not correct. The puffer fish increased by 100 in 1 year. No, in 1 year it went up 50. Each year it increased by 25%. Well, so you could look at, there's a couple of different ways to do this. You could make a list in spreadsheets and write your equation. We could say 0 and 100. We could say 1 and 50. I'm sorry, 150. 2 and 225. Or you could also double check the last one first if you don't want to do the math just yet. The pufferfish started at 100 in 2012. So this would be our A value, and it is also our y-intercept. We see it here and we see it here. So that is the answer. Or again, you could go in and you could do your list and spreadsheets to double check that 25%. But that would entirely be up to you if you decided to do that. If you're happy with that last answer, because you could see it, that works too. But again, up to you, X and Y. So here you can see the equation would have been 100, which even that just reinforces letter D, times 1.5 to the X. So this is saying that it went, had an increase of 50%, in fact, not 25%. Here we have another one. Just again, we're putting it into our calculator to see what that equation is. So, and again, that's probably the most tedious part of this. 4, 1185, 987, 861, 776, 693, menu 4, 1, and A, because it still says it is exponential right here. So we're still doing that, X and Y. So when we write this, A is 1150 and our B is 0.087. We can call it 7. So notice that our B values are fractions here. There is only one where the A value matches, but you could also take those fractions and you could see which one equals. So for B, 987 divided by 1185. And when you, so, and as a decimal, that's pretty close. So there you have it. Plus it's the only one where the A matches. All right, so what is the asymptote when we look at this graph? So again, we can simply create the graph of this and see. So 3 parentheses. And again, you can also do this in Desmos. Just a little easier for me to type it on here for the screen. And we can see right here, it gets super, super close to this. So y equals 0. Make sure, because it is an equation, an asymptote is an equation, so you need to make sure you put that y equals. If you just write 0, that is not the same thing. What's the value of the y-intercept? That's going to be your A. So this is a very straightforward question, 55.3. We talked about sequences the other day. We said be very careful right here. This little number is your X and the big number is your Y. So I can say 1 and 6. And then we said really the only part of this you need is here. And this is multiplying. So this says multiply by 4. So I'm going to have to say 6 times 4 and I get 24. And then I would say 24 times 4 and I would get 96. And it's talking about the first 4 terms. So if I come over to my answers here, all of them start with 6, but the only one that has 24 in that second spot is letter A. This one is also a sequence. Same concept, X and Y. So if I made a little table here, 1 and 3, not -1. X is my little one, right? So 3 and -1, 4 and -3, 5 and -5. And you can do a couple of things here. Notice these are all in y equals mx plus b format. So you can do menu 413 if you wanted to. If you're using Desmos, you could use your table y1 squiggle mx1 plus b, whichever you prefer. You should be able to see though that in fact this is subtracting 2 each time. So you should know that it's not going to be either of these. If you just wanted to double check it, you could plug it in just to make sure. -1, -3, -5. And this one would be linear. So menu 4, 1, and 3. And we can see, so -2x plus 5. So it would be B. So pay attention if it's linear, quadratic, or exponential. Last page. Which statement is true for all of these? So we can see this happens to be a quadratic. We need to change and move everything over to one side. 3/4 x squared minus 3. I am going to use Desmos for this one. It's just a little bit easier to see. So I'm going to come over here. 3/4 x squared minus 3. So I can see a lot of things here. I can see my roots. I can see my vertex, right? So I know this is also my axis of symmetry. So I'm going to go ahead. I'm just going to sketch this on my paper so I don't have to keep going back and forth. So, and it happens to be a minimum vertex. And then I have a root at -2 and +2. So, and then if we remember, our axis of symmetry is always an x equals equation because we're going through this x-axis. So this happens to be x equals 0 for my axis of symmetry. So if we're looking at our answer choices, the axis of symmetry is y equals 0. No. Okay, that's going to be your asymptote, right? So y equals 0 is going to be this line here. So we don't want that. The positive x-intercept is 2, 0. That is a true statement. The minimum value is 0. That is not true. Your min value is always your k. So it is a min vertex, but your min value is that lowest y value. So the min value is actually -3. The y-intercept is 0, -3. That is true. The axis of symmetry is x equals 0. Yes. The positive x-intercept is at -2, 0. No. All right. All right. Our last one, you guys, we really need to make sure we're paying attention and we're using very, very specific points when we're graphing in Eduphoria. So we're going to put this into Desmos and look for those key pieces. I know on our last test, some of us, we tried to put x or y intercepts at half parts, and that did not work. If we tried to put it at a half point, sorry, that should be an x. So here's our equation. So I have 0, 6. Now, I don't have another dot to click on here because there's no min or max vertex. There's no x-intercepts. We have a y-intercept. So we can definitely start at 0, 6. So I'm going to write that over here, 0, 6. Now, what you could do is you could come and use, first of all, I'm going to circle exponential. I forgot to do that. You could come and use the yellow calculator because that is going to give you a table as well. You can also get a table with the Desmos, and I'll show you that as well. So there's the same graph. So if you're more comfortable with the yellow calculator, Control T, 0, 6, and 1, 4. So we could use those 2 points. If you're using Desmos, if you click the little cog, you can get the table this way as well. And you see there's 0, 6, and 1, 4. And that will put the dots on there if you remember to do the table that way. If you're more comfortable with the table on the yellow calculator, you can do that. So 0, 6, and 1, 4. And here is that graph. Now it also, so it says click 2 specific points, not decimals, draw the graph. Draw a dotted line for the asymptote. So our asymptote is always, always y equals 0. So you're going to have to do that in the computer. I hope this was helpful. If you have any questions, please make sure you ask.